Okay, so any questions regarding yesterday?
No.
Yeah, it's pretty simple, straightforward, I guess. So yesterday, what we did is we take this data set, right? So actually, I need to run this. Okay, so essentially, like if you want to run the whole script, you just click Control Shift Enter. So Control Shift Enter means running the whole script. Good. So we take this dataset and fig2 underscore ds. So since the variable names contain values, we are going to create two columns. So this row, we create two columns. Okay, so if you want to run on selected scripts, then you just select a few lines up to where you want and then click run. So basically we created two columns. The first column contains two values, so it is still not a tidy data. So here we separate, basically we just split, right? Split the column called name into sample and cytokine. So that's essentially what we did up to this point. Okay, now, so far, if you look at the script, that is pretty much okay, right? So we are good to graph. So let's do that. So basically we created this data set. So we will call it as fib2 long, okay? Or you can call it whatever you want. Again, like it does not really matter, but it should make sense. So there is the data set for figure 2 in long format. Okay, so there is nothing nothing new there. So next step, we are going to create a ggplot, the plot that we want. Okay, so let's think about the graph. So imagine if you're doing this, you should already know what you want, right? So we will create a graph. So on x-axis, so there is the x-axis. What do we want? There is the cytokine, okay? And then on y-axis, it is going to be the values of these cytokines. Okay, so that's the basic there. So first we need to put our data set. So the data set we are going to use is fing2 underscore long. We give it a typing, and then we say ggplot. That is a function for all ggplot, like the base plot. And then up here, you can see that ggplot has a few arguments, okay? We can call them as inputs. For example, we have a data argument and then mapping, right? So you don't need to know about that, but the one we are going to give here, the one we are going to define is called aesthetic, denoted by a function name AES. Okay, so this AES means static of the graph, which is like X, Y, Z, color, shape, size, etc., etc. Okay. But anyway, mostly it is going to be X, Y, and Z, whatever, right? X, Y. So here in our case, we say X equal cytokine, and then Y equal volumes, okay? So here, on X axis, we want the cytokine names. On Y axis, we want to display the values of each cytokine. Now, this is going to be the basic graph, so we can just run it. Okay, so now we can already see the graph is forming, right? So we have the, on X axis, we have cytokine, like this, we have cytokine. On Y axis, we have the values. But look at this. We have cytokine, but it is in a random order, right? So actually it is fine as long as, I mean, if you want this, it is okay. But there are two things that we want to change. One, for example, IF and A, so interferon alpha 2A, we want this with a symbol, right? Interferon alpha 2A. And then interleukin 1A, instead of A, we want alpha, right? Or maybe just that. So we want interferon alpha 2A, right? So we want that. So we can, where do we need to change? We want to change here, okay? Here, when we change our data set, okay? So we will say, give it a pipe so that the modifying data set goes to the next line. Then we say mutate because we want to change the variables. Okay, so we are going to write a few segments there. So we are going to give in an enter. So press enter. And then we say, okay, so we have sample and cytokine. We are going to change in a cytokine. So cytokine equal, we will say that, okay, if else, we will say that cytokine equal IFN A to A, okay? And if that is the case, then we want to change it to this one, okay? So here is, I gave a different example. I mean, you can also like copy this and change it. You can just take this as well, but I will try here I use if else to change the value of cytokine, okay? So let's say if the value of cytokine is equal to IFN, sorry, it should be IFN A2A, and then we give it the value to this one, okay, this with the symbol. If not, then we say we keep the same cytokine value, okay? So this is how it is written. And then let's select all these and run this. Okay, so you may think that nothing has changed, but in fact, if you look very closely, you see that the symbol has changed, okay? But this statement is okay if we want like a few if you want to change one value, right? But what if we want to change multiple values? So in that case, this is not an efficient way to do that. So that's why we have to use if case when, okay? So essentially what it means is that it is also work the same as if else, right? Many if else. So if cytokine value is equal to this, then we change into this. if cytokine value is equal to this, and we change into this symbol, etc., etc. Okay. And then this statement means that, okay, if else, like if the cytokine values is something else, then we will just give it the original values. Okay. So I mean, you can also type, but I mean, if you know the structure, you don't really have to type, right? Okay. So anyway, maybe let's just, I will just quickly type. So I would say that, okay, maybe not. I would just copy paste, right? Because I have to do this because like, in this like example, I use a capital C. So that's why I need to change everything to be consistent. Otherwise my code won't work. Okay. So anyway, this is like an example. It does not have to be like, there has to be the way you want to plot, right? You want the way you want the plots to appear. So when I run this, you may notice that this label change, okay? So you see now we have a symbol like MIG1 beta, right? MIG3 alpha, something like that. So this is just to give you an example. It's not like, this may not be the exact thing that we want. But anyway, okay, if you have any question, just interrupt me, okay? Otherwise, we will continue. Okay, this is the first thing. The second thing, we want this cytokine to be in an order, okay? Right now, it is ordered alphabetically, but we don't want that. Maybe like the concept here is we want certain cytokines to be in the front, right? For example, we want to start with interferon alpha 2A, maybe followed by interferon interleukin 6, interleukin IP10, etc., etc. Okay, so it has, the idea is you want the cytokine order to be in an order that you want. Okay, so this is what is happened here, right? So we use the function called factor. So basically, if it is a factor, which means that it has, there will be a category, like order category. Okay. This is called level in R. So the function is cytokine equal factor, and then you put the cytokine name again, and then you basically specifying the level that you want, okay, with a C. Okay, it is going to be the same as like this one, right? It is called, it is basically make a concatenation. Anyway, yeah, so let's give it an enter, like press enter. And then, so this is the order that I want, okay? So let's give it. And then imagine that like, yeah, you forget one category, okay? So let's delete this one. And then when you run it, imagine the category that we just remove is MMP9, right? So it is going to be NA. So when I run this, see the change, the cytokines are arranged in an order that we have put there. But since we removed the last one, MMP9, it is replaced with the value NA, okay? So you have to be very careful not to miss any category. So, okay, let me run it again, and then now MMP9 is back. So this is just like a base, like a blank canvas, right? With some preparation for the plots to be driven to be drawn. So the next step is we have to think about which what kind of geometry we want to put on, right? So based on the graph, you can see the graph here. We have like a dot, right? We have a dot spread around. So there are essentially like two things that we can put. One is called GOM point, okay? Let's put it here and then see if it works. So sometimes ggplot is like an exploration. You can put certain geometry and see how it runs out, right? So this is rather okay. But you see in each cytokine, you only see one line, right? Essentially, we want two lines with the Cman and CVS comparison. Okay, so to do that, basically, you just modifying here by putting color, because we want to color we want to create two groups defined by color, right? So we say color, and then we say it is sample. Okay, we want to give colors based on the sample. And then when you run it, see, it is separating two colors, but it is not put into groups side by side. The reason is that GOM point is not a good function to basically like avoiding these dots and putting it as a side by side graph. So you have to use what is called jitter. Like it is something like putting points spread across and side by side, right? So anyway, let's run this and you will see a bit more dots spread across, right? So it has some width and it has some length. Sorry, it has some height. But anyway, we are not going to mess with the height. We are going to mess a little bit with width. But you can play around with, you know, these settings, but sometimes, I mean, I have written that already, so it is okay, right? So you can just copy this and run it. But like the other thing we can put is the position, okay? So right now, like we have two groups separated, but still the points are, I mean, they are a bit better than GOM point, but still they are overlapping. So we want, we don't want these points to be overlapped. So we do this by specifying the position using what is called a position dodge, okay? And then we give it a width, like how apart they will be separated. So let's say like we give it like 0.1, okay? It's like a, I mean, there are some mechanisms behind it. Is more of like exploratory for us. Okay, so for 0.1, it doesn't seem to do a bit well, right? Okay, so because this position dodge is for RGOM, not for a jitter. Okay, so we have to use here what is called a position jitter dodge. Okay, so let's run this, and you will see that it is now even like it is separating out. You know, it's like pulling these two groups apart in each cytokine column. So, but it does not look very nice because a lot of points are still overlapped. So we just give it like, okay, we will give it, I don't know, 2. And you can try like, okay, maybe less 5. Okay, so 5, if you give 0.5, it is starting to like, you know, pull towards each other again. So maybe we would just keep like, I don't know, 4. Or yeah, there are still some overlap. So it's a matter of like, you know, eyeballing and look at, you know, whether the graph looks nice. And that's the main thing. There's no really like specific value that you have to put, right? So I think like about 2.5 or 3 is the best thing, right? So if you want, like, you can put 0.2 because it's give more of a bit separation, nice separation. Okay. Now we got these separated already, right? And the next step is like we need to change. First, we need to we need to remove exit label. Like we don't want to say that it's cytokine because we already know that it's cytokine. So the X exit does not need to be labeled. But for Y exits, we need to be labeled. Okay. But before we do that, right? For the Y exits, we want it to be on log time scale. Okay, so we can put a plus sign. So remember, for the ggplot, it's a plus sign, okay, to combine the commands. But for the other tidyverse functions, it is a pipe symbol to combine the function. Okay, so the next line is we are going to put the Y exits on the log scale, okay? So I don't even think that I have done this here. So you can see it is, oh, okay. So I think this is already in Logtown, right? Or is it? Do you know? Hi, Dosen. Do I lose you? If you are speaking, I think you are muted. Hi, Dosen.
Hi, Mio.
Yeah, I'm just saying that this values are already on Logtown scale, isn't it?
Yes.
Okay. So I'm doing right? So otherwise we need to put these value on a log time scale. Okay, so anyway, so we don't need to put this why is it to be on a log scale, so we can skip that. And then we need to change the label, right? So as I said, so I say x equal to, just give it a quotation, blank, and then press enter. And y, for y, we can just say, I mean, we can just copy this, right? So it does not need to be spelled out, and then run this. So actually, it is already like to be presentable already. So you got on x is the cytokine, y is it the values, and then you got the separation, right? But here the point is to replicate the graphs here. So we do a little bit more than that, okay? So now, if you look at that, if you look at the graph, this graph or the graph in the article, you will see that they put a dot line on at 0, and then the y-axis goes from -2 to 8. It's okay, but it's okay if we just leave it there, but we can modify, fine-tune this graph, right? Okay, so we want to change the y-axis limit from -2 to 8. So we do this by scale y continuous, okay? Because we want to scale the y-axis on a continuous manner. And here we are using two inputs. One is the breaks, okay? The breaks mean like so here like it goes from 0 to 2, 4, 6, right? So the break is on a number 2. So we do this by -2, 0, sorry, -2, 0, 2, 4, 6, 8. okay? I mean, I can even run it here and see what happens, okay? So let's run it here. Now you can see that nothing has changed, right? Because like, even I put the breaks, ggplot already consider like this breaks doesn't make sense because the values are all above 0. So we have to put limits, okay? Limit takes two values, the start and the end. So we gave it, the start is -2, the end is 8. So when we do that, you see the graph is the graph got a little bit taller because it goes from -2 to 8. Okay. So this is what I mean by like challenge the solution. Like if you remember from the checklist yesterday, you have to look at the graph and see what needs to be modified, right? It's not like one straight typing to get a script. It's like repetition, right? You check the result, you go back to your script, you just modify a few codes, go back to your graph, do it again many times. Okay, any question up to this point?
No, I'm good.
Yeah, I mean, these are pretty straightforward, right? So, okay, let's think about it. The next step, we want to put the dotted line here at 0, right? So we just do that, give it a plus sign. And then for that, we are using GOM again. And for like, there are many GOM, right? So in order to get familiar with them, you have to use them and many times. Anyway, we want a horizontal line that goes at 0. So we put H line, right? So you can pretty much imagine H is horizontal line. And again, the most important point here is to specify y-intercept, okay? Where on the y-axis are we going to put this horizontal line? Okay, so y-axis is going to be 0 because we know that's where we want it. So now we got a line, but this is not the line we want, right? So it's been a solid line, solid black line. We don't want that. We want a dotted line. So we say line type, say dotted, okay? I mean, you can change the color, like color red, and then run it, and it's going to be the color red. But yeah, I mean, you can do that, but we're not going to do that, okay? I mean, it's pretty much look nice. So let me run it again to get it back to get a color black. Okay, now, so we got this horizontal line, we got the y-axis limit fixed. Now we need the color, the color separation by to define CMAN and CVS groups to be red and blue, okay? So we have we will do that. So give it a plus sign, and then we say scale because we define this group by giving the color comment, okay? Yeah, the color equals symbol. So that's why the symbol CVS and C1 groups, they got separated. So we have to say scale, we are going to scale color, but we are going to do the manual, okay? So scale color manual, and then we are going to define the values. So it has two groups. So we will say two values. So we will combine with concatenate with C, and then say the first group is red, the second group is blue. That's pretty much it. So you see the first group is red, the other group is blue. If you want the first group to be blue, then you just change the position. Okay, now good. So we are very close, right? Now, okay, almost done. we want this graph presenting. Okay, so we want this black and white, white background. As of now, we have a like grid background, and our exit lines, x exit lines and y exit lines, they are not drawn, right? So we will fix that using ggprism package. Okay, so we will say ggprism 2 dots because we want to use a function from ggprism package. We say team prism. Okay, and then let us run this. See, voila. Now we got the team already. But for the legend, so you see the legend, CVS and Seaman, we don't want it to be on the right side. We want it to the top. Okay. Okay, so to do that, we give a plus sign and then say team. Okay. And then we change legend dot position to be top. So we will put the legend on the top position. That's what it means. See, voila. So we have that. But again, like it does not look good because we got the font size, larger font size, right? So we want to make the font size a little bit smaller. To do that, we will say in the team prism, we say base size equal, I don't know, 14. Let's say pretty much the same. So we will reduce dramatically to 10. Okay. Font size 10. It looks okay now, right? Font size 10. Yeah, I mean, if you want to rotate the label, then you can do that, like all kinds of modifications that you can think of. But it's okay for our purpose, so we will leave it there. So now the only thing that is missing is the p-value. So you see we have a p-value here, pretty nice. Okay. So before we do that, any question? Oh, we got
No
Faisal
question.
joining. Hey Faisal, how are you?
Hi, Mayo.
Hey Faisal.
I forgot about it. Yeah, I just remembered, and yeah, I guess I'll be lost definitely. But yeah, I'll just watch you and see.
Okay.
Probably I'll get something. Yeah.
Yeah.
So
I mean
what are you
this
doing
session
now?
is on recording, so I mean I will also put the video recording for you guys. So sorry, you are asking?
No.
Hey Faisal, you were asking something?
Yeah, I said are you still on the design plotting of the graph?
Mm-hmm.
Oh, okay. Yes, I'll
Yeah,
just
I mean we are almost there, so but anyway, like it's not very complicated, right? So you can watch the first video that I posted on Slack
yeah.
yesterday. I mean, if you want to follow it, like do you have the link, this link? It is on Slack. So
Okay.
yeah, I mean, if you want to follow it, then open it and then start. I mean, start from here. Like what you can do is like if you see a code chunk like this one, like in about, you just click this button. So it's basically copy all the code and then paste it on your RStudio, like run it. So run this chunk, okay? And then you can also run, one by one, copy this and put it on your RStudio. Okay, but we are almost there. So maybe you can just, I don't know, listen, and then If you have any questions, then we can do some Q&A as well.
Yeah, I'll just listen. Even now, I'm not able to join. I'm using actually. I use my phone, so I'm not able to use my
Okay, no problem.
yeah. So I'll just watch and then yeah, I totally forgot about it.
Okay, no problem. Okay, so yeah, I mean, so this is pretty much all done, except that we need to put the p-values, right? So to get a p-value, we need to do something. We need to calculate it before we can put it, right? So let's do that. So before, I mean, you have to put before you create a graph. So I will put it around here. And we will use the same data set, the long format. So that is why it is really important you change to your long format so that the data manipulation and additional calculations will be easier. And then, okay, let's imagine this, okay? So we have this long format, 3 columns. And what do we want? We want to compare CVS and Siemens groups in each cytokine, okay? So in each cytokine. So we want to group by the cytokine, okay? We want to group this p-value by cytokine and compare the value by the sample type. So that is what we are going to do. So we say that this is a new package, okay? So, I mean, you can call using library or we can just use what is called this with 2 dots, okay? The packages are statics. It's a difficult name. We have already installed using the script earlier. Okay, and then the function is we are going to group this p-value. So we will use the function called group by. We are going to group by the cytokine name, okay, the cytokine name. And then we are going to calculate using Wilcoxon test, okay? So there are 2 things, right? So it could be a pairwise, so it couldn't be a pairwise. Let's see, right? But if you are using your own data set, you should already know whether this should be a pair data set or it will be just n pair Wilcoxon test. Anyway, so now we have this Wilcoxon test, Wilcox_test function. We're going to write the formula, like the formula for the test. So the first thing should be the numerical value, which is the value. And it is separated by a tilde sign. And usually that is on your keyboard, that is usually below the escape key. So this is called a tilde sign or tilde symbol, right? And then this is going to be group by symbol, okay? So let's run this. Okay, so now you see we got cytokine, each cytokine, 11 cytokine. We got already p-values. Okay, so this is what we want exactly. For each cytokine, for each column, we will put p-value between the sample. Now, in order to add to the ggplot, we need to add what is called the X and Y position, right? So on which X and Y position of the graph, we want to put the p-value. So it is very easy. Like, it is just to explain you, but the implementation is you put R status, and then you say at XY position, and usually that's enough. Okay, so, and then it's going to add a few more X, Y position, etc., right? And then, we will do what is called the converting p-value to symbol. Okay, so we have the p-value. I mean, it's one thing if you want to put the value itself on the graph, but sometimes usually what we do is we put one asterisk for those p-value less than 0.05, 2 asterisk for less than 0.01, 3 asterisk for less than 0.001, right? So we will do that. We will change it here. So we say mutate. What do we say? P significant? I don't know. Otherwise, like P symbol. You can call pretty much anything you want, okay? And then you have to say if else. So for this part, you have to start with the smallest number, okay? So the smallest number is p-value less than 0.01. And then we go to 0.01, and then we go to 0.05, okay? You will see what I mean by that. Okay, so we use the function called if else, and then say p-value, if p-value 0.001, we say 3 asterisk. Okay, so this is the condition. So if else statement, we check the, well, not we, but I check the statement. If the statement is correct, it gives this value. If it is not correct, it's give this value again, right? So if p-value is less than 0.001, it gives 3 asterisk. If not, then we continue to the next one. Okay, so give it an enter, like press enter, and we will do it again. If else, if p-value less than 0.01, we give it 2 asterisk. Okay, now you get a gist, right? Go to the next level and we say if else p-value less than 0.05, then we give it 1 asterisk. Okay. Okay, so which means that this thing is basically greater than or equal 0.005. So which we will say that non-significant. Or you can say, or you can remove this non-significant thing. But anyway, it's up to you. Okay, let me run this. Now you might not see it, but it is there. Okay, so here it has a P symbol, which we create a P symbol. Okay, we call it P values. Okay, I mean, you can pretty much call it whatever you want. It's okay. So it is P value. Now we got it. We got a P value database, and then you can check it again. Like bring your mouse arrow here and click that, and then you can just see here. Okay, it is already there. P symbol. Okay. Now again, imagine if you want to run pair Wellknown test, you can just easily put pair equal true. Okay, that is basically running a pair Wellknown test. And if I run this, it's going to give me, I think the same, right? But a little bit different p-value based on the calculation. Anyway, that is how you run a pair Wellknown test. Okay, it's not very complicated. Now, any question up to this point?
No.
So we will put the p-value here. Okay, so we will give a plus sign. I mean, you can give it here, or you can just, you know, go to like any line on this ggplot this area, right? So I mean, basically this ggplot graph is created as a layer, right? So first we basically create a foundation, then we give it a geometry jitter. We're just basically trying to make this look like this, and then to separate it, we give it color, and then we change the label. So it's like it goes one layer after layer. And then we change this and we give a horizontal line, we change the color, and then we give the theme. and that's equivalent to graph prism. Okay, so anyway, I will put it here. And the function is basically the same, ggprism, and then we say add p-value, and now I say is we have to give the p-value here, okay, p-value, and then give a plus sign. So essentially, I think it is now working. Okay, I think it's because I put the color somewhere here. Okay, it might be the reason. So what I can do is I can move this to here, right? But anyway, it's okay, just to make it more consistent. So it's a lot messier, but I think, let me just quickly change. It's not that, right? Okay, so you know what? Let's just use this X and Y, okay? Let's not use this at X and Y position. Let's just use this. I mean, the code is already there, so I'm not going to change, I mean, at this point. But anyway, I think this should be C cytokine. Let me quickly do a few things. Okay, then perfect, right? So basically, I mean, you can even you can change these position by yourself, or you can add X and Y position and it will automatically do it for you. Okay. So I mean, it is another option. But if you want to use this, okay, let's copy this. So let's run this, and then by doing that, we are only giving the X position, not Y position. So that's why you have to define your own Y position. I think that makes a little bit, I mean, if you want to manually do that, that is okay. Otherwise, you can also do it automatically like this one, okay? And then one thing we can just changes here is the label, okay? Label equal, you can just say label, or sorry, the label should be the P underscore symbol, right? So that is what we want. Or I think you have to put in quotation. Oh, right. Okay, let's use this one, okay? Because the other one, you already got a code here. So you can just copy paste, but it is a new code. It's okay. So see, it's already there. So you got a nice, but check with this one. This one looks a little bit nice because like we have a, we are arranging some, there are some similarity between the p-value bar, but that is okay, like totally okay. Okay, so yeah, that's it. Like that is our figure 2. So now we will say that there is figure 2, fig 2. Okay, and then we just you know delete this. Okay, so just go over the broom sign and then say yes. So this is remove everything for the plot, and then you just run this again. Oh wait, oh I have to run this line. Run this line. So basically this, calling the object, this object fig2, basically you can look at the plot. Okay, so any questions up to this point?
No.
Yeah, I mean, it's pretty straightforward. The code is already there. And then you know why we do most things, right? So, I mean, even like I have already written some codes already there, but when I actually rewrite the whole exercise, the codes are somehow a little bit different, right? It's okay. That is okay because sometimes you can improvise, so your codes can be a little bit different. I think I will stop here, and then next Thursday and Friday, I think we will continue from there. Do you have any question?
No, not for me.
Is it too fast or is it too
Huh?